In PCB production, the testing and inspection process begins with automated optical systems. AOI scans the panels to detect opens, shorts, pattern defects, and any deviations from the intended image. High-resolution cameras compare the circuitry to the digital data, and anything outside the tolerance window is flagged for review. AVI follows with a more detailed surface inspection. This stage focuses on areas where visual accuracy is critical, confirming solder mask quality, text clarity, and surface features that may not appear in electrical tests. By combining AOI and AVI, the inspection process catches issues early and removes the risk of missed defects that can occur with manual review alone. Electrical performance is then verified through flying probe testing. This method doesn't require a dedicated fixture, so it's ideal for low to medium volumes or quick-turn work. Multiple probes move across the board to confirm continuity, isolation, and precise resistance values. Four-wire testing supports accurate low-ohm measurements on power circuits and dense HDI layouts. For higher volume production, dedicated test fixtures are used to perform fast, repeatable electrical checks across every board in a batch. These fixtures ensure that all nets and connections perform within the expected range before the job moves forward. Dimensional inspection equipment verifies outlines, hole locations, slot sizes, and critical mechanical features. This helps ensure the routed profile and drilled features match the customer's drawing within the required accuracy. Final quality control includes a combination of visual review, documentation checks, and confirmation that all electrical and mechanical criteria have been met. To validate materials and finishes, the process continues inside the lab. Instruments measure plating thickness, evaluate impedance values, and confirm environmental compliance requirements such as RoHS. These lab checks verify that the copper, surface finishes, and substrates meet both industry standards and customer expectations. By combining optical inspection, electrical testing, dimensional verification, and laboratory analysis, the full process ensures that every PCB leaving the factory meets the accuracy and reliability needed for modern electronic designs.